Welcome to this explainer. Today we're looking at an incredible piece of hardware that is quietly solving literally one of the biggest bottlenecks in modern tech. We're talking about Supermicro's liquid-to-air or L2A Sidecar CDU. If you're operating a legacy data center right now, you're probably staring down the barrel of some massive AI workloads and wondering how on earth you're going to keep those servers from melting down without basically tearing up your entire building. Well, this sidecar is the ultimate technological bridge. It's designed to seamlessly upgrade your existing infrastructure, and today we're going to break down exactly how it works.
Okay, let's dive right in. 500. That's the magic number you need to keep in mind today. Modern AI and high-performance computing racks are absolutely pushing the limits of physics, demanding cooling capacities of up to 500 kilowatts per rack. I mean, just think about that for a second. That is a massive amount of heat. If you try to shove a 500 kilowatt AI cluster into a traditional air-cooled data center, the existing air conditioning infrastructure is going to be completely overwhelmed. The servers would throttle, or worse, just shut down entirely. Honestly, this massive heat density is the main barrier to entry for the AI revolution.
So to understand how we conquer this barrier, here's our roadmap for the explainer. First, we'll cover the AI cooling challenge. Second, the L2A Sidecar solution. Third, how it's built for high reliability. Fourth, we'll compare specs, looking at the 200 kilowatt versus the 500 kilowatt models. And finally, accelerating AI deployments. Let's get to it.
Kicking things off with Section 1, the AI cooling challenge.
So the main headache every operator faces right now is this severe mismatch between these next-generation ultra-hot AI compute clusters and older legacy air conditioning infrastructure. If you want to bring in high-density AI, conventional wisdom says, well, you need traditional water cooling. But look at what that actually requires. You're talking about retrofitting your entire facility with primary water loops, installing massive cooling towers outside, and taking on just unbelievable construction costs and downtime. It is a logistical nightmare. But on the flip side, we have the L2A Sidecar cooling approach. This completely bypasses the facility overhaul. It leverages your existing air-cooled infrastructure to rapidly deploy liquid cooling directly at the rack level. It's a total game changer for facility management.
Which brings us to Section 2, the L2A Sidecar solution.
So how exactly do you get liquid cooling performance without installing all that liquid facility infrastructure? Well, when you look inside the L2A Sidecar, you immediately notice this intricate, heavy-duty piping and those blue N+1 redundant pumps down at the base. What you're looking at is a fully closed-loop design. That means the liquid cooling loop is 100% contained right there within the rack. It is totally isolated from the facility's primary water system. And why is that absolutely crucial? Because by keeping the liquid strictly inside this contained ecosystem, you practically eliminate the risk of disastrous leaks splashing onto your adjacent IT equipment. It traps the heat in the liquid, pulls it to the sidecar, and just exhales it as warm air.
And when you see this out on the data center floor, the brilliance of the design really clicks. With the sidecar open, you get a clear view of those striking green variable frequency drive, or VFD fans. And when it's closed up and seamlessly integrated into a massive server row, you really see the scale of it. Because it's this flexible standalone unit, it just attaches right to your high-density AI clusters. You absolutely do not need to shut down your facility to lay down new water mains. You literally wheel it in, attach it to the rack, and suddenly your standard air-cooled room is supporting high-density, liquid-cooled computing. It's modularity at its finest, built to handle the 24/7 strain of heavy AI workloads without breaking a sweat.
Moving right along to Section 3. Built for high reliability. We can actually break this highly reliable thermal cycle down into 4 super straightforward steps. Step 1. The liquid runs through the servers and absorbs that massive high-density heat right at the source, right off the chips themselves. Step 2. That superheated, contained liquid travels out of the server and straight into the sidecar. Step 3, and this is really where the magic happens, the VFD fans kick in, dynamically adjusting to the exact heat load. And finally, Step 4, the heat is safely rejected and exhausted out into the room's ambient air where your normal facility air conditioners can easily handle the diffused heat. It's essentially a completely self-contained cooling ecosystem working in perfect harmony. Now, I really want to zoom in on Step 3 for a second. The source documentation specifically notes, integrated with variable frequency drives, it can adjust fan speed intelligently based on real-time thermal demand. This adaptive feature is huge, guys. It means the sidecar isn't just mindlessly blasting fans at 100% power all day long. It's reading the thermal output of your AI cluster second by second. When demand spikes, the fans speed up. When the compute load drops, the fans slow right down. This drastically reduces power consumption, giving you a much greener, cost-saving operation, all without ever sacrificing peak thermal performance.
All right, let's talk hardware in Section 4. Specs, 200 kilowatt versus 500 kilowatt.
For the IT pros and facility engineers tuning in, let's put these two main models side by side. First up, we've got the 200 kilowatt cooling capacity model. Its maximum power consumption to run the Sidecar is 19 kilowatts, and it weighs in at a pretty hefty 1,145 kilograms. And mind you, that is before you even add the coolant. Then, look at the beast next to it, the 500 kilowatt capacity model. To support that insane cooling threshold, its maximum power consumption jumps to 55 kilowatts, and the dry weight literally doubles to 2,300 kilograms. The physical footprint expands too. The 500 kilowatt model is 2,200 millimeters wide, compared to just 1,100 millimeters for the smaller unit. Make no mistake, these are heavy-duty, serious pieces of enterprise hardware.
Now, if you're a facility manager, seeing a weight of 2,300 kilograms probably makes you sweat just a little bit when you start thinking about logistics and shipping docks. But here is the saving grace from the documentation. The 500 kilowatt model is designed with a modular architecture. What this means is that for transportation, each module maintains a footprint that is very similar to the 200 kilowatt Sidecar. You get comparable packaging dimensions and shipping weights. So even though you're bringing in half a megawatt of cooling power, getting it shipped, transported through your facility doors, and installed remains completely manageable.
And finally, Section 5, accelerating AI deployments.
So, we've got the raw cooling power sorted, and we know we can safely get it into the building. But a cooling system like this is honestly only as good as its reliability and management features, right? Well, Supermicro guarantees maximized uptime through built-in redundancy. The Sidecar comes with redundant power supply units, or PSUs, and an automatic transfer switch. So if one power source drops, the cooling doesn't even blink. It just keeps running during critical power disruptions. Plus, managing the whole setup is super straightforward. There's an intuitive built-in touchscreen right on the rack, along with an Ethernet web UI. And for seamless integration into the management platforms you're already using, it fully supports industry standards, SNMP version 2C, Redfish, RESTful APIs, and Supermicro's own SuperCloud Composer. You get real-time centralized monitoring of your temperature, pressure, flow rate, and pump status literally right at your fingertips.
So we've seen how the L2A Sidecar masterfully bridges the gap between the staggering heat of modern AI workloads and the very real limitations of legacy air cooling. It lets you completely bypass facility overhauls, provides highly isolated liquid cooling, and ensures redundant, efficient uptime. But I want to leave you with a pretty provocative question to chew on. As AI compute density continues its meteoric rise year after year, could modular bridge technologies like the L2A Sidecar stop being seen as just a temporary retrofit and actually become the permanent new standard for flexible data center architecture? It's definitely a fascinating thought. Thank you so much for joining me for this explainer, and keep innovating.